right, this is the second video of lesson 9, and we're on page 2. We're on number 2 on page 79 in your book. So please make sure you're there and recording the notes along with us. Okay, so here we have a problem, 28 times 63. And we know we can interpret this problem as 28 63s or 63 28s. So for our practice together, let's think of it as 28 63s, which means that we're going to be finding a total of 28 groups of 63. All right. So let's think about an estimate, 28 groups of 63. Let's see. Can I keep my pen? All right, 28 groups of 63. Nope, got to use these pens. So bossy. Okay, 28. Rounded to the nearest 10. 30, right? The 8 tells me I'm closer to 2 than I am closer to 3 than I am to 2. And 63, 60, because the 6 tells me I'm closer to 60 than I am to 70, right? So 6 times 3 is 18. Oh, got to do my squiggly line for an estimate. 3 times 6 is 18. So 1,800 is a good estimate. Always good to have an estimate because sometimes we put in an extra 0 or we leave off a 0 and it can throw us way off. Okay, so we're going to use the standard algorithm on this one. And 63, 28, right? 28 groups of 63. All right, so we're going to think about 8 ones times 3 ones, okay? Thinking about it in unit form, 8 ones times 3 ones, that would be 24. 8 times 3 is 24, carry the 2, right? And then 8 ones times 60, or 6 tens, right? 6 times 8 is 48, plus 2 is 50, right? 48 plus 2 is 50. And then we need to have our magic 0 because now we're moving to 20. 2 tens times 3. 2 times 3 is 6. And our 0 automatically is going to make it tens, right? And 6 times 2 is 12. We don't need to carry because we don't have anything else here blocking our way, right? And then we're going to add it together. 4, 6, 7, 5 plus 2 is 7, and 1. 1,763. All right, and we can see our partial products, 504 and 1,260. Now, what does this 504 represent? What does the 504 show us? It is 8 63s, right? 504 is 8 63s. What about 1,260? What does it represent? 20 63s, right? So if you're thinking about the distributive property that we talked about in the last lesson, we could say that we're breaking our 8 times 63, right? 8 times 63 plus 20 times 63. Do you see how we're distributing the 63 to both the 20 and the 8, and the 20 and the 8 are from the 28. And then we have our two partial products, right? Part answers, partial answers, and the total answer is 1,764, which represents 28 groups of 63, right? If we interpret the equation as 63 groups of 28 instead, would we have a different number of partial products? Would we have more than 2 partial products? We would still have 2, right? Yep, we would still have 2. Good job. All right, let's keep going and let's look at number 3. in your book. All right. I think it's on the next page, page 80. All right. Flat back turtles. I don't know what a flat back turtle is, but we could say the same for green sea turtles or honoea, right? Flat back turtles lay 52 eggs in a nest. How many turtle eggs would there be in 427 nests? Wow, 427 nests. So we have a word problem. What could we draw to go with our word problem? Let's draw. I'm thinking about a tape diagram. Yeah? Can you draw a tape diagram on yours as well? Okay. And I'm thinking that there's 52 eggs in a nest. So here's a nest with 52, right? And the question is, how many eggs would there be in 427 nests? So that's my unknown, right? How many eggs are there in 427 nests? And I can put my 3 dots. I do not have to draw 52 427 times. I can just write 427 and I have my 3 dots. So that means I have 427 52s. All right. So now I kind of know what the problem looks like. I'm thinking about the area model and I'm thinking about standard algorithm, right? What expression could we use to determine the number of turtle eggs? 52 times 427, right? That's our expression that tells us the number of turtle eggs. Let's look at some possible area models. Okay, there we have 2 area models, right? What do you notice about those 2 area models? This one has 427 here, broken by place value, and 52 here. This one has 52 on the top and 427, and they're all divided by place value, right? Does it matter whether you have the 50 or the 2 here? No, you can switch them, all right? It's kind of like personal preference, right? We could say that A is 52 groups of 427, and B is 427 groups of 52. So our unit is the number on the top because that's the one that's being repeated in the multiplication. That's how I like to think about it, right? So I have 52, 52, 52, 52, 52, 52, 52. And over here I have 427, 427, 52 times. Okay. All right. Now let's think about the connection between the area model and the standard algorithm. How many partial products are there going to be in each model? How many partial products are there going to be? Well, I can see right here there's going to be 2, right? Because I'm going to do 1, and it's going to be by place value, but all 3 numbers can go together and make 1 number. And then here's another one. And then here there's going to be 3, right? Because I have 3 levels, because I have 3 digits, right? Okay. All right, so why don't you go ahead and find the answer to that one for your Ed puzzle, right? This would be number 1 in your Ed puzzle. Lesson 9, video 1. I don't know. Are we in video 1? I'm losing track of things, aren't I? I think we are. No, probably video 2. Sorry about that, but you'll do the Ed puzzle. Okay, thank you very much. And here are some possible, right? Here's what you hopefully have in your area models for those in your Ed puzzle. And do you see that the partial products are different, right? Here we have 854 to 21,350. And here we have 364, 1,040, and 20,800. Why are they different? Yeah, exactly right. Because here we have 2 times 427, and here we have 7 times 52. It's going to be different, right? But it's still the same answer, 22,204. Okay, awesome. Very good job. All right, thanks so much. I'll see you in the next video.